Hello everybody, so welcome back to PW International Boards where we are learning the chapters topic wise here. So I am your mathematics mentor and in today's session we are going to cover one more topic for Cambridge IGCSE Mathematics for the paper code 0580. The topic that we are going to cover in today's session is sequence, which is a part of your chapter 2, that is algebra and graph. So talking about what all we are going to have as the subtopics for today's session, it comprises of the sequence, arithmetic sequences, formulas for the terms of an arithmetic sequence, sequences with quadratic and cubic rules. Along with that, we will be learning about the exponential sequences, applications of exponential sequences and the combination of sequences. Along with solving the different topics, along with learning the different topics, we will also be solving the previous year questions here. So moving to the first topic here, that is a sequence. Firstly, we need to understand that what is actually a sequence, right? So in order to talk about the definition of a sequence is something where we are talking about a collection of terms arranged in any specific order. So we need to understand that what is the order being followed there, right? But if we talk about a sequence, that is something where we are talking about a pattern or where we are talking about the collection of terms that are arranged in a specific order, right? Each term in the sequence is obtained according to a rule. So there is going to be a set rule, there is going to be a defined rule whenever we talk about finding the next term, right, in any particular sequence. Correct? So here if I talk about these examples that we have been given with, which says 1, 8, 27, 64, 125. So can we just actually observe a pattern here? Can we observe a sequence here? Correct? So when we are talking about the first term, right, it is 1. When we are talking about the second term, it is 8. And what is actually 8? Do we know this thing that 8 is nothing but the cube of 2? If we talk about 27, that is a third term here. 27 is nothing but the cube of 3, right? Later on, if we talk about 64, it is nothing but the cube of 4. If we talk about 125, it is nothing but the cube of 5. So can we just observe a sequence here, a pattern here? Correct? Further, if we talk about the second example that we have here, right? So first, let me just write that what is a pattern, what is a sequence here. So this is 1 cube, then we have is 2 cube, then we have is 3 cube, 4 cube, 5 cube. This is the sequence that we have here. Talking about the second sequence, it is 3, 6, 9, 12, 15, 18. So this is nothing but the multiples of 3 that we can see. So first term is 3 multiplied with 1. Second term is 3 multiplied with 2. Third term is 3 multiplied with 3. So if we talk about the fifth term, it is nothing but 3 multiplied with 5. Sixth term is nothing but 3 multiplied with 6. Clearly? So if I talk about this is nothing but 3 multiplied with 1, then 3 multiplied with 2. Then we talk of 3 multiplied with 3. Then we can see 3 multiplied with 4. This is the pattern that we can observe here. Correct? Now further, if we talk about the terms of a sequence can be expressed as, so whenever we are talking about that how we are going to express a different term, so that is being expressed as u1, u2, u3 till un. So here if we talk about un, it is nothing but the nth term of the particular sequence. So if we are talking about u1, it is the first term. U2 is going to be the second term, U3 is going to be the third term, while if we talk about UN, that is going to be the nth term of that particular sequence. Okay, further if we talk about U1 is the first term, U2 is the second term and UN is going to be your nth term of that particular sequence. Clear? Other than that, if we need to write that what is going to be the terms here, we either write it with a U or we can use A as well. Okay. Further, if we talk about the arithmetic sequences that we are going to learn here, right? So in this sequence, if we observe, there is a common difference between the successive terms. Correct? So firstly, let's just observe that what is the common difference here. So in order to get the common difference, what we are going to do, we are going to subtract the two consecutive terms. Okay? So here what we can observe, from in order to go from -6 to 1, what we need to do? We need to add 7 to it. Then only we are going to get from -6 to 1. If we need to go from 1 to 8, we are going to again add 7 to it. Then from 8 to 14, we are again going to add 7 to it. From 15 to 22, we are again going to add 7 to it, right? So what we can observe here that the common difference in this particular sequence is nothing but 7. Okay, so here if I talk about the common difference, it is 7. Clear? Moving further, if we talk about that how we are going to get the formulas for the terms of an arithmetic expression or terms of an arithmetic sequence, correct? So here if I talk about, let's say that I am asking you that what is going to be the 100th term of this particular sequence. How are we going to calculate it? So let's learn it here. So if we talk about the term to term rule, so a term to term rule tells you how to generate the next term in the sequence, correct? So the pattern can be shown by drawing it in this way. So here if I talk about then from 2, then 8, 14, 20, 26, 32. So what we can observe here is that the common difference in the terms is nothing but 6, okay? So when I'm using the term common difference, that means we are talking about the difference of the two consecutive terms. So the term for it we are going to use in the throughout the session and in general is a common difference. Okay. So example, draw a diagram to show how each of the following sequences continues and find the next 3 terms in this particular sequence. Okay. So here if I talk about the example, right, if we need to get the terms here, right. So first let's solve the first example. I'm just solving it on the side, which is 3, then we have is 9, then we have is 27, then we have is 81, then we have is 243, correct? So what we can see that in order to get the next term, we are actually multiplying it by 3. Yes, because if we'll just observe here, so this is multiplied with 3, then again we are multiplying with 3, then again we are multiplying with 3, right? So again we are multiplying with 3, right? So in order to get the next term, we are going to follow the same thing here, right? So we are going to multiply this by 3 and the term that we are going to get after multiplying it by 3 is going to be nothing but 729, correct? Further, if we need to get the next term here, right, again we are going to multiply it by 3. So let's use the calculator in order to get the answer. We are getting it as 729 multiplied with 3 is going to be 2187 as a next term, right? As a question is saying this thing that we need to get 3 terms here, right? So we are again going to multiply it with 3. So now again we are going to just multiply it with 3. So what are we going to get? Let's do the calculation. So we are getting it as 6561. So these are going to be the next 3 terms. Okay. So this is how you are going to calculate them here. Understood? Now moving to the second point here, a formula for the nth term of the sequence. Algebraically, this can be written in as a formula for the nth term. So firstly, let's just understand that what is the method of finding out. Whenever you find that there is a common difference between 2 consecutive terms and that difference is constant throughout in that particular sequence, then we talk about that what is going to be the formula for the nth term of that sequence. Okay, so let's just understand this thing here, that when n is equal to 1 or when we are talking about the first position, so in that case the value of the term is 2. When n is equal to 2, in that case the value of the term is 5. What we can observe next is that when n is equal to 3, the value of the term is 8, right? And then if we talk about when n is equal to 4, in that case what we can observe here is that the value of the term is 11. So can we observe one thing here, that there is a common difference, and if we talk about the common difference here, it is a +3 sequence, correct? Can we observe this thing? That in order to get the succeeding term, we are adding 3 to it, right? Just in case I am asking you what is going to be the next term here, you will do simply 14 plus 3, which is going to be nothing but 17 here, right? So here, if we need to find out that what is actually the formula in order to get the nth term here, so whenever we see a common difference, that progression we call as an arithmetic progression. Okay, so if I talk about what we call that particular sequence as, we call it as an arithmetic progression. And whenever you find that we need to get the nth term, so that is going to be the general formula is an is equal to a plus n minus 1 multiplied with d. Okay, so now if I talk about, then you must be thinking that what is this a here? So a is nothing but the first term of the sequence. So if I talk about the first term of the sequence here, what we can observe here is 2 plus n minus 1 multiplied with a common difference. So here we are doing +3 in order to get the next term. So the common difference here is nothing but 3. So if we need to get the nth term here, this is going to be nothing but 2 plus 3n minus 3. Correct? So that is going to be 3n minus 1. This is going to be the formula in order to get the nth term of the sequence. So as I told you, you can either represent it with an or you can represent it with un as it is mentioned here. Clear? Now, the common difference is the coefficient of n, right? Whatever the common difference that we can see, which is we can see a common difference of 3 here. So, it is going to be the coefficient of n, correct? The constant is then calculated by determining the number needed to complete the term. Okay, so here we can find it out by using this formula. Understood? Now, moving to the next example here, right? So, if we are given with the position here that says that when n is equal to 1, the term is equal to 7. When n is equal to 2, the term is equal to 9. So, what we can observe here is that the common difference here is nothing but 2. Correct? So, let's just put it in the formula that we have just now learned. Clearly, if I talk about the nth term here, that is going to be u1 plus n minus 1 multiplied with the common difference. So, u1 first term is nothing but 7 plus n minus 1 multiplied with the common difference is 2. So, that is going to be 7 plus 2n minus 2. So, we are going to get the nth term as nothing but 2n plus 5, which is mentioned here. Clear? This is how we are going to calculate the nth term of any particular sequence. Understood? Now, moving to one more question on this, right? So, here the question says, let's firstly read and understand what the question is all about. So, question here says, for each of the following sequences, the term to term rule and one of the terms are given. Calculate the terms required and state whether the sequence generated is arithmetic or not. So, in order to say this thing that the sequence generated is in an arithmetic sequence, in that case, simply what we are going to do here is, we need to check that is there any common difference here? Understood? That how we are going to solve this particular thing? So, let's just read the first part of it. So, here if we are being provided with u1 in the first sequence, right? So, u1 is equal to 2. In order to get the value of u2, it is going to be u1 plus 5. So, that is going to be equal to 2 plus 5, which is nothing but 7. In order to get the value of u3, it is going to be u2 plus 5. Correct? So, that is going to be 7 plus 5, which is equal to nothing but 12. In order to get the fourth term, this is going to u4 is equal to u3 plus 5. So, that is going to be equal to 12 plus 5, right, which is nothing but 17. So, what we can observe here is that if we just write the terms which goes as 2, 7, 12, 17, we can observe that there is a common difference of 5. So, clearly if there is a common difference, it is an arithmetic progression or an arithmetic sequence. Understood? Moving to the next part of the question, which says that when u3 is equal to 10, we need to get the value of u1, u2 and u3. Okay, so u3 is already being provided to us, right? So, we are simply going to write it as it is. But in order to get the value of u2, we know this thing that u3 is equal to nothing but u2 over 2 minus 1. Correct? So, we'll just put the value of u3, which is equal to 10, is equal to u2 over 2 minus 1. That is what we are going to get here, right? So, this is going to be nothing but u2 over 2 is equal to 11. So, in order to get the value of u2 is going to be nothing but 22. Correct? Yes. Further, if we need to get the value of u1, correct? So, we know this thing that u2 will be equal to u1 over 2 minus 1. So, this is going to be 22 is equal to u1 over 2 minus 1. Correct? So, further if we talk about, we are going to get u1 is equal to 23 multiplied with 2, which is going to be equal to 46. Correct? So, here what we can observe that in this particular sequence, what is happening, the terms that we have got here goes as, the first term is 46, then we can see the next term as 22, the next term is 10. So, here if I will talk about the common difference, the common difference here is minus 24. Here we can say this thing that the common difference is minus 12. So, clearly when the common difference is not same, it is not an arithmetic sequence. Understood? Okay. Now, moving to the next question, which says here, copy and complete each of the following tables of the arithmetic sequence. So, we are being provided with that what is the formula for finding the nth term of the sequence. Correct? So, we know this thing that un here is equal to nothing but 4n minus 3. Correct? So, if we need to get u1, right? So, in that case, u1 is going to be 4 multiplied with 1 minus 3, which is going to be equal to 1. So, we are simply going to write 1 in this particular block. Okay. Secondly, if I talk about finding out that what is going to be u2, so u2 is going to be 4 multiplied with 2 minus 3, which is going to be 8 minus 3, that is 5. So we will be writing 5 here. Clear? Further, if I talk about the next value here, right, so that is going to be u5. That is what we are being asked, that we need to keep the n is equal to 5 here. So that is going to be 4 multiplied with 5 minus 3, that is 20 minus 3, which is 17. So we are simply going to write 17 in this box. Now we are being provided with the value of the nth term, and we need to get that what is that particular term is at which particular position. So in that case, if we need to get it, so what we will do, we will simply do 45 is equal to 4n minus 3. Correct? So we will be getting 4n is equal to 45 plus 3. So we will get n is equal to 48 over 4, that is nothing but 12. So clearly we have got the value as 12 here. Right? Now the next is when n is equal to 50, what is going to be the value of the term? So if we need to get what is u50 here, so that is 4 multiplied with 50 minus 3. So that is nothing but 200 minus 3, which is going to be 197. Is that clear? Understood? Now, moving to the next question, using a table if necessary, find the formula for finding the nth term for each. Okay, so here what we need to observe, that what is this particular sequence. So let's just find out that what is going to be the nth term in this particular sequence. So moving to the first example here, that says 0. I'm just copying down the sequence again, so that in order to have better understanding. Correct? So here if I talk about, if I talk about the sequence here, so can we just observe this thing, that this is nothing but, so clear, if we talk about the common difference here, this is 19, this is, if I talk about the common difference here, so clearly if I'll talk about, let's just do the subtraction here, what are we getting? 63 minus 26 is going to be equal to 37. Correct? So if I talk about the common difference, this is 61. So clearly this is not an arithmetic progression that we are getting. Yes, as the common difference is not same throughout. So though we are going to learn one more approach for solving it in the coming slides, right? But let's firstly understand that if we don't know that particular method, that how we can find out the cubic sequences, in that case how we can solve it. So what we can observe here is that 0 is nothing but 1 cube minus 1. If we talk about 7, we know 7 is a second term, which is 2 cube minus 1. If I talk about 26, 26 is 3 cube minus 1. Can we observe this thing here? So clearly if I talk about 0 is equal to 1 cube minus 1. If I talk about that what is 7, 7 is nothing but 2 cube minus 1. If I talk about 26 is nothing but 3 cube minus 1. Correct? If I talk about 63, it is nothing but 4 cube minus 1. So can we just find out that what is a general formula that we are using here? So here if I talk about, in order to get the value of un, it is nothing but n cube minus 1 is the general formula for finding the nth term of this sequence. Understood? Moving to the next question here, that says 3, 11, 29, 66, 127. So again, if we talk about, looks similar to what we have just now learned. Correct? So here if I talk about, let me just take a note of the sequence again. 11, 29, 66. So whenever we can observe this thing, that the numbers here are changing in the pattern of a cube. Correct? Correct? So I can write this as nothing but 1 cube plus 2. Can we write it like this? If I talk about this thing, this number is nothing but 2 cube plus 2, which is, just a second, this has to be 10 here. Let me check. Just a second. So here this digit has to be 10 here. There's an error. Right? So I'll just change it here as well. So this has to be 10. So this is going to be 2 cube plus 2. Further, if I talk about, this is going to be nothing but 3 cube plus 2. Correct? This is nothing but 4 cube plus 2. Right? And this is nothing but 5 cube plus 2. So if I need to find out that what is the nth term of the sequence, it is nothing but un is nothing but n cube plus 2. Is that clear? Are we clear with what is going to be the nth term of this particular sequence? Now, moving to the next question, which is a previous year question, right? So here we are being provided with a series which is 4, 11, 18. So can we observe this thing, that this is nothing but a plus 7 series? Yes. So here if we'll just observe, then in order to get the nth term of it, right, so un is going to be nothing but u1 plus n minus 1 multiplied with d. So first term here is 4 plus n minus 1 multiplied with a common difference which is 7. So this is going to be nothing but 7n minus 3. Is that clear? Yes. Now, moving to the next question, which is again a previous year question. The nth term of a different sequence is 4n minus 3. Work out the first three terms. So, in order to get the first three terms, we will be keeping the value of n 1, 2 and 3 respectively. So, when n is equal to 1, we will be getting 4n minus 3 will be equal to 4 multiplied with 1 minus 3. So, I'll just write it u1 is equal to, so that is going to be equal to 4 minus 3 which is 1. When n is equal to 2, in that case if we need to get the value of the second term, that is going to be 4 multiplied with 2 minus 3 which is going to be 8 minus 3, that is 5. When n will be equal to 3, it is going to be 4 multiplied with 3 minus 3 which is going to be 12 minus 3, that is nothing but 9. Understood? Yes? Now, moving to the next important thing, right? This is an extremely important thing for all of you to understand, because many of the times we get questions related to the quadratic rules and the cubic rules, right? So, let's just understand this particular part here. So, it is a sequence of numbers in which the second differences between terms are constant. So, whatever sequences that we have learned so far, if we talk about the arithmetic sequences, there we were observing that there is a common difference between the consecutive terms. But here the second point is that it is a sequence of numbers in which the second difference between the terms are constant. Okay, we'll be just taking the examples on it. The nth term of a quadratic sequence is generally expressed as an square plus bn plus c. So, if we talk about the general formula for finding that what is going to be the nth term of the particular sequence, we write it with an square plus bn plus c. Okay. Now, moving further, I know that you must be having many questions right now that what is this a, b and c here, right? So, we'll be just understanding in a while now. So, if we talk about that, we have been given with a sequence which is 2, 6, 12, 20, 30. Correct? So, let's just firstly write it. I'm just writing the sequence here. 2, 6, 12, 20 and 30, right? So, now if I'll just find out the common difference here, this is going to be 4, this is going to be 6, this is going to be 8, this is going to be equal to 10. Now, the first thought that you will be having in your mind after just going through it says that whatever the common difference that we have got here, there is a sequence in the common difference now. Yes, if I just get the common difference of the common difference, then, so that is going to be 2, again this is going to be 2 and this is going to be 2. So, whenever we find the second difference to be constant, that is where we call it as the quadratic sequence. Understood? Firstly, we need to understand that what is actually a quadratic sequence. So, when the second difference is common, right, or second difference is same throughout, we call it as a quadratic sequence. Clear? Now, so if we need to find out that using the second difference calculate A, and from the equation using specific terms to solve B and C, hence the rules for nth term is therefore a quadratic which takes the form un is equal to an square plus bn plus c. Now, I know that you must be having many questions related to this, right? So, let me just help you in understanding this particular thing. Okay. Let me just take an example for your understanding, right? That because I know that you must be having this thing in your mind that how we are going to get that what is this A, B and C here, right? So, clearly let's just do one thing. Let's just take one sequence here which is 1, 7, 17, 31, 49. Let's take this as an example. So, if I talk about the common difference here, what we can see as a common difference is 6, then we can see as 10, then we can see the common difference as 14, and then we can see the common difference as 18. Further, the common difference, the second difference is 4, the second difference is 4, the second difference is 4. Clearly, this is a quadratic, a quadratic sequence that we can see here. Now, how we are going to solve this particular thing? So, whenever you may take any of the row, right? You can take maybe this row or you can take this row, that is entirely fine. Okay, I'm just taking the first one. So, in this case, what it is going to be, in order to get the value of that, how we are going to write it in the form of an square plus bn plus c. So, clearly we need to get the value of a, b and c here. So, in order to get the value of a, b and c, clearly the the term that where we can see the common difference is getting same now. In that particular sequence, you will be taking this equal to 2a always. Okay, you will always be taking this equal to 2a, right? You will be taking this equal to nothing but 3a plus b. Okay, whenever there is a quadratic rule that shows up, you will always be taking the bottommost term as 2a, right? The term in the middle will be taken as 3a plus b, while the one on the top, or we can say the first term, will be taken as a plus b plus c. Is that clear? Okay, so now when we know this thing that 2a is equal to 4, we know this thing that a is equal to 2. Clearly, we can get this value. Further, if we know this thing that 3a plus b is equal to nothing but 6, clearly, if I just put the value of a, so we will be getting b is equal to 0 here. Yes, further, we know this thing that a plus b plus c is equal to a plus b plus c is equal to 1. So, a is equal to 2 plus b is equal to 0 plus c is equal to 1. So, we are getting the value of c is equal to minus 1. So, by that we have got the value of a, b and c. So, we can substitute it in the formula. So, if I talk about that, what is going to be the formula for finding the nth term of the given sequence, it is going to be equal to, in this particular sequence, it is going to be 2n square, as b is 0. So, we are going to just neglect that particular term, minus 1. So, let's just try it. Are we getting the answer by using this formula? So, let's say that I am just taking n is equal to 4 here. Taking an example. So, when I am going to take n is equal to 4, it is 4 square is nothing but 16. 16 multiplied by 2 is 32, minus 1 is 31. So, we are getting the right answer. Let's check it for maybe one more value. Let's take n is equal to 5. So, n square is going to be 25. 25 multiplied with 2 is equal to 50. Minus 1 is 49, which is the fifth term of the sequence. So, whatever the general formula that we have got, or whatever the expression that we have got for the nth term of this particular sequence is definitely right here. Okay. Now, moving to the next type of sequence that we have as a cubic sequence. Okay, so this is something which is going to be of uttermost importance here, that this is equal to 2a, this is equal to 3a plus b, and this is equal to a plus b plus c. Clear? Now, moving to the next type of sequence, which is a cubic sequence. So, in that case, if we talk about a cubic sequence is a sequence of numbers in which the third difference between the terms are constant. The nth term of the cubic sequence is expressed as an cube plus bn square plus cn plus d. Okay. So, now again, as we have got a formula for calculating the value of a, b, c in the quadratic rules, right? So, similarly, we will be having the formula for the cubic rules as well, for the cubic sequences as well. Okay. So, here if I talk about that, we are being given with the sequence, like there is an example given, the first difference and the second difference, then the third difference is the constant here. So, the way in the quadratic sequence, the second difference was constant. In the cubic rules, the third difference is going to be constant. Understood? So, here, we are going to solve for the values of b, c and a, b, c and d. Correct. So, firstly, let's just take it with the help of an example, right? Let's just understand this thing. Taking an example here, right, we have is 4, 14, 40, 88, 164, right? So, firstly, let's just get the common difference here. This is nothing but 10. Then we are having as nothing but 26. Then we are having it as 48. And then we are having it as 76, right? Further, this is coming out to be 16. If I do it, this is going to be 22. Right, this is going to be nothing but 28. Further, if I talk about this, we are getting the common difference as 6. So, the third difference that we are getting here is constant. Understood? Now, as we know this thing, that the general formula for writing this is an cube plus bn square plus cn plus d. Correct? So, here if I talk about when we are going to take the first row here, right? We will be taking this particular row. So, as we got the thumb rule for the quadratic, we are going to have it similarly for the cubic as well, where this first one is equal to 6a, always. Okay. Further, if I talk about the one above it, will be taken as 12a plus, so this is equal to 12a plus 2b. Clear? If I talk about the third one, that is equal to 7a plus 3b plus c. Okay, and the top one would be A plus B plus C plus D, the way we were doing it previously. Okay? Understood? So you need to take a note of this thing. It is very important for you to know. Okay? So now moving forward, if I talk about, then we know this thing that 6A is equal to 6. So we are getting A is equal to 1. Clearly. So now we know this thing. The second one is 12A plus 2B is equal to 16 here. Correct. So we are going to get it as 2B is equal to 4. So we are getting B is equal to 2. So we have got A and B here. Right. Further, we know this thing that 7A plus 3B plus C is equal to 10 here. So 7 plus 6 plus C is equal to 10. So we are getting C is equal to minus 3. And we know this thing that A plus B plus C plus D is equal to A plus B plus C plus D is equal to 4. Correct. So let's just put the value 1 plus 2 minus 3 plus D is equal to 4. So we are getting D is equal to 4 here. That is what we are getting as the values. Correct. So further, if we need to just solve it, if we need to write the final sequence here, so what are we getting as a final sequence? So we are getting the final sequence here as 1n cube plus 2n square, as we are getting C is equal to minus 3. So minus 3n plus 4. That is what we are getting as the general formula for getting this sequence. Right. So we can check our answer by substituting the value. Maybe we can put n is equal to 3 here. Right. So in that case, taking an example here, if I am going to put n is equal to 3, what we are going to get here is, I am just writing it here. So in that case, n cube will be equal to 27. Right. N square will be equal to 9. 9 multiplied by 2 is going to be 18. Minus 3 multiplied with 3, which is going to be 9 plus 4. Right. So this is going to 27 plus 9 is 36. 36 plus 4 is 40. So we are getting the correct answer. That means that whatever the sequence that we have got, or whatever the formula for the general term we have got, is absolutely right here. But yes, I am again repeating this thing, that we need to know this thing, that this is equal to 6A, this is equal to 12A plus 2B, this is equal to 7A plus 3B plus C, and this is equal to A plus B plus C plus D. Is that clear? I hope that we have understood this thing. Now, moving to a question on this, by using a table if necessary, find the formula for the nth term of each of the following sequences. So we need to get the formula for the nth term. So firstly, let's just understand that what is the common pattern that we can observe, and what type of sequence it is. So just writing down the sequence here, which is 2, 5, 10, 17, 26. So here common difference is 3, here the common difference is 5, here the common difference is 7, here the common difference is nothing but 9. So clearly we can see this thing, that the second difference is constant here. Correct. So we are going, it is a quadratic sequence. So in that case, if I talk about, the general formula is an square. So un will be equal to an square plus bn plus c. Correct. So we are just going to use the formula here. Clearly we know this thing here, that, so just making a circle on it, we know this thing that 2a will be equal to 2. So that means we are going to get a is equal to 1 here. Right. Further, we know this thing that 3a plus b will be equal to 3 here. So I'm just going to put the value. So we are getting b is equal to 3a plus b is equal to 0. So we are getting b is equal to 3 and b is equal to 0. And we also know this thing that a plus b plus c is equal to 2 here. Correct. So that is equal to 1 plus 0 plus c is equal to 2. So we are getting c is equal to 1. So these are the values of a, b and c that we are getting. So talking about the general formula here, that is going to be a is equal to, so n square plus n is what we are getting, plus 1 is what we are getting as the general formula. So let's just try it with some of the terms. So if I just put n is equal to 4 here, in that case it is going to be 4 square plus 1, which is 16 plus 1, that is 17. So clearly the formula that we have got is absolutely right here. Moving to the next part here, which says 0, 3. So let's just do it 0, 3, 8, 15, 24. So here it is, the common difference is 3, here the common difference is 5, here the common difference is 7, here the common difference is 9. So clearly we can observe this thing, that the second difference is constant. Right. So the nth term would be equal to an square plus bn plus c. So let's just get the value of a, b and c here. So On marking the given sequence that we are going to use here, right? So we will be getting that 2a would be equal to 2. So that means a will be equal to 1. Further, if I talk about 3a plus b will be equal to 3 now. That is what we have as a sequence. So that is going to be 3 multiplied with 1 plus b is equal to 3. So we are getting b is equal to 0. Correct. Further, we know this thing that a plus b plus c would be equal to 0 here. Right. So a is equal to 1, b is equal to 0 plus c is equal to 0. So we are getting c is equal to minus 1. So if I talk about the sequence here that we have got, the final sequence is going to be un would be equal to n square minus 1. So let's just do it. Are we getting it right? So let's take, for instance, let's take n is equal to 5 here. In that case, if we'll put n square minus 1, it is going to be 5 square minus 1, which is going to be equal to 25 minus 1, that is 24. So clearly our answer is correct here. Further, if I talk about the third example that we can see, so this is minus 2, 1, 6, 13. Let me just write it in some less space so that we'll have space to solve the question. So minus 2, 1, 6, 13, 22. So here if I talk about the common difference, it is 3. Here it is 5. Here it is 7. Here it is 9. So again 2, 2, 2. Clearly the second difference is constant. So if we talk about the general formula, that is going to be an square plus bn plus c. Correct. So we know this thing that 2a would be equal to 2. So we will be getting a is equal to 1 here. Clear. Now further we know this thing that 3a plus b would be equal to 3. So again we are going to get b is equal to 0. And if I talk about a plus b plus c, that is equal to minus 2. So that is going to be 1 plus 0 plus c is equal to minus 2. So we will be getting the value of c is equal to minus 3. So if I talk about the general formula here, that is going to be un would be equal to n square minus 3. Let's calculate this, right? So here if I talk about, let's take n is equal to 4 here. N is equal to, n square will be 16 minus 3 is 13. So that is what we can see as the value of the fourth term. So that means that whatever the formula for the nth term that we have got here is absolutely right. Clear? Now, moving to the next question here, right, where it talks about some more sequences. Use a table to find the formula for the nth term of the following sequences. So, let's just move on to the first sequence that we can see here. So, here the sequence is 11, 18, 37, 74, 135. So, let's just calculate that what is going to be the nth term for this particular sequence. So, firstly, if I'll just take a note of what we have just now learned, that for a cubic sequence, what are the terms? It is 6a, 12a plus 2b, right? So if I talk about the terms here, right? So clearly what we have got is 6a, then we have is 12a plus 2b, correct? And if I talk about for the third one, it is nothing but 7a plus 3b plus c, and the fourth one is a plus b plus c plus d, correct? These are the four values where we need to equate it to. So now let's just find out that what is the common difference here. So the common difference here is 7. Later on we can observe this thing that the common difference here is 18, 19. Further, after doing the calculation, we are getting the common difference as 37. Then we are getting the common difference as 61. Talking about the next difference here, that is going to be 12. Further, we are getting it as 18, and then we are getting it as 24. Later on, this is coming out to be 6 and this is coming out to be 6. So what we can observe here is that the third difference is same. So that means we are going to use the cubic method. So if I talk about that, what is the general term here? It is an cube plus bn square plus cn plus d. Yes. And further, if I talk about, we have learned this thing as I mentioned on top. So this is going to be equal to 6a. So this is going to be the required numbers. So here, this is going to be equal to 6a, right? This is going to be equal to 12a plus 2b. This is going to be equal to 7a plus 3b plus c. And if I talk about this one, this is going to be a plus b plus c plus d, correct? So if I talk about, clearly we have got that 6a is equal to 6. So we have got a is equal to 1. Further, it says, so we will just put a box around it. So that is 12 this is 12a, right? So this is 12a plus 2b is equal to 12. So that is 12 multiplied with 1 plus 2b is equal to 12. So we are getting b is equal to 0. Further, if I talk about solving for c, what are we getting as a value of c here? So this is 7a plus 3b plus c is equal to 0. Yes, no, so it is not equal to 0, it is equal to 7, right? So that is going to be 7 multiplied with 1 plus 3 multiplied with 0 plus c is equal to 7, right? So what are we getting here? That c is coming out to be equal to 0. Further, we know this thing that a plus b plus c plus d is equal to 11. So substituting the values 1 plus 0 plus 0 plus d is equal to 11. So we are getting the value of d is equal to, nothing but 10. So talking about that, what is the sequence? The nth term for for this particular sequence is going to be equal to a is equal to 1. So this is going to be n cube plus 10. So let's just use it, right? If I talk about n is equal to 4 maybe again. So it talks about that n cube will be equal to 64 plus 10 is 74. That means whatever the general formula that we have got here is absolutely right. Clear? Now, moving on to the second subpart of the question, which provides us a sequence as 0, 6, 24, 60, 120, right? So here the common difference is 6. Then we can see the common difference as 18. Then we can see the common difference as 36. Then we can see the common difference as 60. Now further, it is 12. Then we can see it as 18. Then we can see this thing as 24. Later on, it is 6, and we can observe this thing that the third difference here that we are getting is the constant. So clearly, if I talk about the general formula for the nth term, it is going to be an cube plus bn square plus cn plus d. That is what we are going to get as a general formula. So let's just find out that what is going to be the value of a, b, c and d here. So clearly, 6a would be equal to 6. We will be getting a is equal to 1. Second value, if we talk about, in that case, it is going to be nothing but, we will do 12a plus 2b. 12a plus 2b would be equal to 12 here, right? So that is going to, we are getting b is equal to 0. That is the second value that we have got. Now talking about the third value here. So we know this thing that here 7a plus 3b plus c would be equal to nothing but 6. So putting all the values here, so we will be getting 7 multiplied with 1 plus 0 plus c would be equal to 6. So we will be getting 6 is equal to, c is equal to minus 1. Later on, we know this thing that a plus b plus c plus d is equal to, so a plus b plus c plus d is equal to nothing but 0, right? So if I talk about the value here, it is going to be 1 plus 0 minus 1 plus d is equal to 0, right? That is what we have as a first. So that means we are getting d is equal to 0. Correct? So let's just talk about that. What is the sequence that we have got here? So un would be equal to, a is 1, right? So it is going to be n cube. B is 0. So we are going to eliminate the term. C is equal to 1. So that is going to be minus n. And d is again 0. So the pattern is n cube minus n. Again, maybe we can take n is equal to 5. So n is equal to 5. If we will take 5 cube is 125 minus 5 is 120. That means whatever the formula that we have got for the general term, it is absolutely right here. Correct? Now, moving to the next sequence here, which says 1, 10, 33, 76, 145. So let's just write the sequence. So this is going to be equal to 9. Here we are getting it as 23. Here we are getting it as 43. That is what we are getting. Yeah. Right. So further, let's just do it. What are we getting here? This is coming out to be 69. Let me just do the calculation. Minus 76 we are getting, yeah, 69. Okay, so always it's important that we are just cross checking the calculations, whatever the calculations that we are doing here, right? So here it is going to be 14, then we are getting it as 20, then we are getting it as 26, and then the third difference we are getting as the constant. So that means if I talk about, then un would be equal to an cube plus bn square plus cn plus d. Correct? So in that case, let's just do this thing that 6a is equal to 6, right? So we will be getting a is equal to 1. Further, if we are going to simply do it as 12a plus 2b would be equal to 14. So we will be getting 2b is equal to 2. So we are getting b is equal to 1 in this particular sequence. Further, if I talk about, we know this thing that 7a plus 3b plus c would be equal to 9 here, right? So substituting all the values, plus 3 multiplied with the value of b plus c is equal to 9. So we are getting this value of c is equal to nothing but -1. Later on, if we need to get the value of a plus b plus c plus d, a plus b plus c plus d would be equal to nothing but 1 here, right? So a is 1 plus 1 minus 1 plus d is equal to 1. So we are getting the value of d is equal to nothing but 1 plus 1 is 2, 1 and 1 minus 1, we are getting the value of d is equal to 0 here. So talking about the general formula here, that is going to be a is 1. So this is going to be n cube plus n square minus n. That is what we are going to get as a general formula, or the formula for the nth term of this particular sequence. So again, we are just going to cross check our answer once by putting maybe n is equal to 4. So when we are going to put n is equal to 4 here, in that case it is going to be 64 minus 64 plus 16 minus 4, right? So we are getting 80 minus 4, which is equal to 76. That means our answer is definitely right here. Clear? Right? So I hope that we have understood this particular part. Correct? Now moving to one more part on the same question, right? So we are doing so many parts so that we are having enough practice of it and we are having all the formulas in our mind. Correct? So let's do the calculation here. So talking about the common difference that we can see here, we are getting the common difference as 12. If I talk about the common difference here is 24. If I talk about the common difference is 42, let's do the calculation. This is coming out to be 66, right? That is what we are getting. So the second difference is 12 and then we can get it as 18, then we can get it as 24. So the third difference that we can observe here is again constant. So we are going to do the same thing. We'll have 6a is equal to 6. So we will be getting a is equal to 1 here, right? Later on we'll do 12a plus 2b would be equal to 12, right? So we are going to get b is equal to 0 now. Further, we'll do 7a plus 3b plus c is equal to 12 here again, right? So later on, if I talk about the substituting the value, so c is going to be nothing but 12 minus 7. So we are going to get the value of c is equal to 5. Further, if I talk about the value of a plus b plus c plus d is equal to 13, let's substitute the values. 1 plus 0 plus 5 plus d is equal to 13. So we are getting the value of d as 13 minus 6, which is going to be equal to 7. So talking about the general expression for writing the nth term of this. So if I talk about the nth term here, so that is going to be n cube as the coefficient, as b is equal to 0. So there isn't going to be any term with n square, right? Plus 5n plus 7. That is what we are going to get as the nth term for this particular sequence. Understood? Now moving to the next question here, which says which term of the sequence un is equal to 2n square plus 5 has the value 167. So clearly we are just going to equate it to 167, which is 2n square plus 5. So this is going to be 2n square would be equal to 167 minus 5. So we will be getting 2n square is equal to 162. So n square would be equal to 81. So we will be getting n is equal to 9. So that means the ninth term would be equal to 167 in this particular sequence. Clear? Now, moving to the next question, which is for the sequence un is equal to 2n square minus 5n plus 3, determine the value of the 10th term. So, we need to get the value of the 10th term. So, clearly, in order to get the value of the 10th term, we will put n is equal to 10. So, u10 would be equal to twice of 10 square minus 5 multiplied with 10 plus 3. So, that is going to be 200 minus 50 plus 3. So, that we are going to get it as 153. Clear? Moving to the next question, where the value of n for which un is equal to 45. So we need to get it as 45 is equal to 2n square minus 5n plus 3. Right. So as we can see, it is a quadratic expression. So we are going to use the quadratic formula in order to solve this. Right. Either we can use a quadratic formula or we can do some splitting as well, middle term split up. So this is going to be 2n square minus 5n. So we'll just have it on the other side. So 5n plus 3 minus 45 is equal to 0. So this is going to be 2n square minus 5n minus 42 is equal to 0. So we can either directly do it by using the quadratic formula, or we can just try that if we can split it. So we need to do the factors of 84 in such a way that we are getting 5. So 84 is nothing but 12 times 7, right? So that is going to be 2n square minus 12n plus 7n minus 42 is equal to 0. So we will be getting 2n, and this is going to be n minus 6 plus 7. N minus 6 is equal to 0. So we will be getting 2n plus 7, just a second, 2n plus 7, and we will be getting n minus 6 is equal to 0. So we will be getting n is equal to either minus 7 by 2, or we will be getting n is equal to 6. So clearly, if we talk about the nth term, right, or any number of term, firstly, it can never be in the fractional form. Secondly, it can never be negative. So we are going to simply ignore this, and this is going to be your answer to where the value of n for which un is equal to 45 is 6. Clear? Moving to the next question, which the pattern that we are going to learn is an exponential sequence. So let's understand that what type of particular sequence we call as an exponential sequence. So it is a sequence in which each term is found by multiplying the previous term by a constant factor. So we need to multiply the previous term with a specific value in order to get the next term. Okay, so example, if I talk about 2, 4, 8, 16, 32. So what the sequence that we can observe here is that we are multiplying the previous term with 2 in order to get the next term. That is what we are doing here, correct? So now there are two ways of describing exponential sequence. The first is a term to term rule, right? We'll be just understanding that what is the pattern that is being followed here, or what type of sequence it is. Then we will be getting the next term of it, right? So if I talk about here in this particular pattern, if we'll observe, then we know in order to get the next term, what we need to do is we need to multiply the previous term with 2. That is what it is, correct? So that is what we call as a term to term rule. Now talking about that, what is the general formula of doing it, right? So if I talk about the formula for the nth term of an exponential sequence, to reach the second term, the calculation is 2 multiplied with 2, right? To reach to the third term, the calculation is 2 multiplied with 2 multiplied with 2, or we can say 2 multiplied by the square of 2. Then if we talk about the general formula here, that goes as the first term multiplied with the common ratio that we can observe raised to the power n minus 1. Okay, and if we talk about whenever you see this thing that there is a common number that is being multiplied in a particular sequence, the way we were calling it as a common difference in the arithmetic progression, here we call it as a common ratio. And this particular type of the sequence is known as a geometric progression. What we call it as? This is known as a geometric progression. Many of the times you will find this word written in the sequence where it says GP or geometric progression. So in the geometric progression, we have a common ratio. That means the term that is being multiplied with the preceding term in order to get the next term. Clear? Okay. Now, moving to the applications of exponential sequence, these are commonly found in real life scenarios such as population growth, radioactive decay, and compound interest calculations. So, there's an example given. Alex deposits $1,500 in his savings account. The interest rate offered by the savings account is 6% each year for a 10-year period. Assuming Alex leaves the money in the account, calculate how much interest he has gained in 10 years. So clearly, if I talk about, this is something where the growth is happening exponentially, right? So we are going to multiply it we are going to multiply it with a common ratio here, as the question is of compound interest, and we already had a session on it, right? That how we can solve the questions on compound interest. So there you will get an idea that how we will be solving this particular question. Okay. Now, moving to the next question, identify which of the following are exponential sequences and which are not. Okay, so talking about the first sequence here, that says 2, then we have is 6, then we have is 18, then we have is 54. So as I told you, for the exponential sequences or for the geometric progression, the common ratio needs to be same, correct? So in order to get the next term, we need to multiply it with 3. Again, in order to get the next term, we need to multiply it by 3. Again, we need to multiply it by 3. So clearly, if we are having the same common ratio, it is a geometric progression. Clear? Or we can say it as an exponential sequence. Clear? Moving to the next one here, if I talk about the next is 25, 5, then we have is 1, then we have is 1 over 5. So if I talk about, we need to divide this by 5. Again, we need to divide this by 5. Again, we need to divide this by 5. So what we can observe here is that in order to find out, what we can see that yes, in order to get the succeeding term, we need to divide the term with 5. Again, what we can observe that there is a sequence here, that every time we need to divide it by 5 itself. So clearly that means that this is a geometric progression or an exponential sequence. Clear? Moving to the combination of sequences now. So another very important thing for you to understand is the combination of sequences. So it is not always going to be like that you will be getting an arithmetic progression or maybe a geometric progression, but many of the times and in the exams you will be getting the questions on the combination of sequences as well. So let's just understand the combination of sequences now. So let's understand through one example. Consider the sequence below, which is 2, 8, 18, 32. By inspection, write the rule for the nth term of the sequence. The terms of the sequence are double those of the sequence or of squares. Therefore, un is equal to 2n square. So what we can observe here is that the first term is equal to 2, second term is equal to 8, third term is 18, fourth term is 32. Correct? So now we need to get that what is going to be the general formula or how we are going to solve this particular pattern, right? So when n is equal to 1, right? So the term is going to be is equal to 2. When n is equal to 2, we are getting it as equal to 8. Correct? So we can see this thing that 8 is nothing but 2 square multiplied with 2. Correct? If when n is equal to 3, we are getting it as 18, which is nothing but 3 square multiplied with 2. Right? And this can be written as 1 square multiplied with 2. Correct? So here we have is when n is equal to 4, we are getting this as 32, which is nothing but 4 square multiplied with 2, which is 16 multiplied by 2 is 32. So if we talk about the nth term for this expression is nothing but 2n square. Correct? Now, write down the next two terms. So we need to write the next two terms of this particular sequence. So firstly, we need to understand that what type of pattern it is. Correct? So here it says 50, then we have a 72. Correct? So we need to have more terms here. So in that way, if we need to get the next two terms of this particular sequence, so clearly when n will be equal to, I'll just write it here. When n will be equal to 5, it is going to be 2 multiplied with 5 square, which is going to be 50. And when n is equal to 6, it is going to be 2 multiplied with 6 square, which is going to be 2 multiplied with 36, that is going to be 72. Is that clear? Now, moving to the next question on this, right? Here the question says in each of the question below, write down the rule for the nth term of the sequence by inspection. Write down the next two terms of the sequence. So, firstly, let's just move on to the first term, right? So, we need to get two things here, right? Firstly is the nth term, right? And then we need to write the next two terms of the given sequence. So, here the sequence is 2, 5. So, what we can observe here is that it is the pattern of n square plus 1, right? So if I talk about that, the general term here is going to be n square plus 1, right? Because 2 is nothing but 1 square plus 1, 5 is nothing but 2 square plus 1, 10 is nothing but 3 square plus 1, correct? So if I talk about, this is the formula for the nth term, correct? If we need to get what is going to be the fifth term, so u5 is going to be 5 square, which is 25 plus 1 is 26. And if we talk about what is going to be sixth term here, so that is going to be equal to 37. Understood? Now, moving to the next question here, we need to write down the next two terms of the given sequence. So here if I talk about what we can observe, so this actually goes as 1 cube plus 2, 2 cube plus 2, 3 cube plus 2. So if I talk about the general formula, this is nothing but n cube plus 2. So if I talk about what is going to be the value of u5 here, so that is going to be 5 cube plus 2, which is going to be 127. And if I talk about what is going to be u6, that is going to be 6 cube plus 2. So that is going to 216 plus 2, which is 218. Clear? Understood? Now, moving to the next sequence that we can see here, that clearly what we can observe that we are multiplying it by 2. Correct? So what we are doing, we are multiplying it by 2. Yes. So in order to get the nth term of this particular sequence, as it is a geometric progression, what we can observe, so un would be equal to the first term multiplied with the common ratio raised to the power n minus 1. Okay. So that is what, if we talk about the general term here, that is going to be 2 raised to the power n minus 1. Okay, so further if I need to get what is going to be the value of u5, so that is going to be 2 raised to the power 5 minus 1, which is nothing but 2 raised to the power 4, that is equal to 16. And if I need to get the sixth term, that is equal to 2 raised to the power 6 minus 1, which is 2 raised to the power 5, that is nothing but 32. Is that clear? Now, moving to the next question, which is a previous year question. Now we will be solving all the previous year questions that we had in the recent year papers in from the topic of sequences, right? So the first question that we are solving is from the recent paper of May-June 24 from the variant 4.3. So here the question says the nth term of a sequence is 120 minus n cube. Find the fourth term of the sequence. Find the value of n when the nth term is equal to minus 1 to 11. Right? So let's just have the first part of it, which says we need to get the fourth term. So we'll put that u4 would be equal to 120 minus 4 cube. Right? So that is going to be 120 minus 64. So let's just do the calculation. What are we getting here? So 120 minus 64 is equal to nothing but 56, correct? So that is a fourth term. Further, the question is saying find the value of n when nth term is equal to minus 1 to 11. So when minus 1 to 11 is equal to 120 minus n cube, right? So clearly if I talk about n cube would be equal to 120 plus 1211. So let's do this calculation. What are we getting here? 1211 plus 120. We are getting it as n cube is equal to 1331. So that means we are getting the value of n is equal to nothing but 11 here. Clear? Understood? Now, moving to the B subpart of the question, which says the nth term of a different sequence is 3 multiplied with 0.2 raised to the power n minus 1. Find the fifth term of the sequence. So if I need to get the fifth term, I'll just put the value of n is equal to n is equal to 5 in the sequence, right? Which is going to be 3 multiplied with 0.2 raised to the power 4. Correct? So if I talk about 0.2 raised to the power 4, that is going to be equal to nothing but 3 multiplied with 0.04, so that is going to be 0.0016, correct? So let's do the calculation. We are going to get this as 0.0016. We are getting it as nothing but 0.0048. Clear? Understood? Now, moving to the next question, right? Next up part of the same question, which says the table shows the first 4 terms of the sequence A, B and C. Complete the table for each sequence. So firstly, if I talk about the sequence A, right, we will be having less space in solving the question. So I'm just starting from the top, okay? So if I talk about the sequence A, what we can observe here is that in this particular sequence, it goes as minus 3, then again we are doing minus 3, then we are doing minus 3. So in order to get the fifth term, we'll again do minus 3 and get the next term as minus 5. So in order to get the nth term here, the common difference is minus 3. So in order to get the nth term here, so here un would be equal to, first term is 7 plus n minus 1 multiplied with the common difference, which is minus 3 here. So this is nothing but 7 plus, this is going to 7 minus 3n plus 3. So we will be getting it as 10 minus 3n is going to be the nth term of this particular sequence. So let's just write it here. This is going to be 10 minus 3n. Okay. So we can even check it for any of the value that we have. Now moving further, if I talk about the second, the B pattern that we can observe here is, right. So I'm just solving the B pattern here. So it says 1, 2, 3, 4 in the numerator, right, and 4, 5, 6, 7 in the denominator. So clearly if I talk about the next term here, 1, 2, 3, 4, then that means the fifth term will have a 5 in the numerator, while if I talk about the denominator, when n is equal to 1, right, the denominator is n plus 3. When n is equal to 2, again the denominator is 2 plus 3, then it is 3 plus 3, then it is 4 plus 3. So that is nothing but 5 plus 3, which is going to be equal to 8. So here it is going to be n over n plus 3. Clear? Now, moving forward to the next part, which is a C part of the question. Let's just understand that what does a C part here say. So, we need not to solve this particular part here. Let's move to the C part. Okay. So, here if I talk about the C part, what does it say? The C sequence. The sequence goes as 0, 2, 6, 12. That is what we can see as a sequence. Now, if we'll just do it, it is the common difference is 2. Here the common difference is 4. Here the common difference is 6. Now, if I talk about the common difference, here it is 2. Then again it is 2. So, what we can observe here is that it is following a quadratic rule here. Right? So, clearly if I talk about, we know this thing that 2a would be equal to 2 here. So, we are going to get a is equal to 1 here. That is what we can understand. Now, moving forward, so this is the particular sequence that we are taking. Correct? So, later, we know this thing that we have learned it that 3a plus b would be equal to 2. Right? So, if we have got the value of a is equal to 1, so that is 3 plus b is equal to 2. So, we are getting the value of b is equal to -1 here. Right, further if we need to get the value of c, we know this thing that a plus b plus c would be equal to 0, a plus b plus c would be equal to 0. So, this is 1 minus 1 plus c is equal to 0. So, we are getting c is equal to 0. So, talking about that, what is going to be the general formula for finding the pattern here is going to be nothing but, we know it is going to be nothing but a n square plus b n plus c, correct. So, that is a is equal to 1. So, this is going to be n square minus n. That is what we are getting here. So, we can just check it in the formula itself that if I check for n is equal to 4, it is going to be 4 square, which is 16 minus 4, that is 12. Correct. So, that means we have got the correct formula. So, we are just going to write it here. This goes as n square minus n. So, in order to get the fifth term, it is going to be 5 square minus 5, which is 25 minus 5, that is nothing but 20. Is that clear? So, this was a question from the paper of May-June 24 from the variant 4-3. Now, moving to the next question, which is from the paper of May-June again from the variant 4-2. Here, these are the first 5 terms of the sequence. Find the nth term of it. Correct? So, if I need to get the nth term, firstly we need to understand that we are going to multiply by 6 in order to get the next term. That is what we are doing here. Correct? So, if I need to get that what is going to be the nth term here, that is going to be a, or we can say that's the first term, which is going to u1, the common ratio raised to the power n minus 1. Correct? So, first term here is 1 over 6, right? Common ratio here, if I talk about, it is 6 raised to the power n minus 1. I can write this as 6 raised to the power minus 1 multiplied with 6 raised to the power n minus 1. So, further, if I talk about the common, the general term here or the nth term of the sequence can be written as 6 raised to the power n minus 2. Clear? Moving to the next question, which is again a question from the paper of May-June 24 from the variant 2-1. So, we need to complete this particular table here. So, in order to complete the table, firstly, let's just understand that in order to get the fifth term, right? So, we will be having this as 60 minus 4 multiplied with 5. So, that is going to be 60 minus 20, which is nothing but 40 here. Correct? Further, if I talk about when n square minus 300, so in that case, it is going to be 5 square minus 300, which is nothing but 25 minus 300, that is going to be nothing but minus 275. Is that clear? Now, find the smallest positive number in the sequence. So, we need to get the smallest positive number in the sequence B. So, in order to get the smallest positive number, this is where we have it, right? So, the sequence is n square minus 300. Just a second, yeah. So, that means we need to have n square minus 300 needs to be greater than 0. So, that means n square needs to be greater than 300. Correct? So, that means if I talk about, then n needs to be greater than the square root of 300. So, that is going to be nothing but, if I talk about the square root of 300, if we'll do it, we will be getting it as 17 point something. So, that means n needs to be equal to 18 in that scenario. Because the square of 17, if we do, that is 289. Correct? So, if I am going to put n is equal to 200, n is equal to 17, we will be getting it as a negative value, because n square minus 300 would be equal to 289 minus 300. Correct? So, that is going to give you a value that is less than 0. So, when n will be equal to 18, you will be getting a positive value here. Understood? Moving to the next question, which is again a question from the paper of May, June 24 from the variant 1-3. So let's just read and understand the question. So it says that we have been given with a sequence where there is a common difference of 7. Correct? So here if I talk about the next term, that is going to be again plus 7. So 24 plus 7 if we'll do, that is going to be 31. Moving forward, if we need to write down the term to term rule for continuing the sequence, so this is going to be nothing but 3 plus the next term is going to be nothing but whatever it is. Then first we have is 3. Just what is happening? So if I talk about the first term that we have here is 3. If I talk about the second term, that is 3 plus 7. If I talk about the third term, that is 3 plus 7 multiplied with 2. Right? Then we can see the fourth term as 3 plus 7 multiplied with 3. That is what we have here. Right? So clearly if I talk about the term to term rule, that is going to be the first term, right? Or we will just write it with u1 plus n minus 1 multiplied with 7. That is what we are going to have as a term to term rule here. Now, we have one more sequence here that goes as, let me just have a look, 16, 14, 11. So here the next sequence is, we have a common difference of -2, then we can see of -3, then we can see of -4. So as the question is saying, we need to write the next two terms of the sequence. So clearly if I talk about the next is going to be a difference of -5 and then we'll have of -6. So 7 minus 5 is nothing but 2 and 2 minus 6 is nothing but -4. That is what we are going to get as the next two terms of the given sequence. Clear? Now, moving to the next question here, which is from the paper of February, March 24 from the variant 2-2. The nth term of the sequence is n square minus 3. Find the first three terms, right? So, u1 is equal to 1 square minus 3, which is equal to -2. If I talk about the value of u2, it is 2 square minus 3, which is equal to 1. If I talk about the third term, it is going to be 3 square minus 3, which is equal to 9 minus 3, that is nothing but 6. Understood? So what we can observe that we are getting so many questions from the topic of sequence in every variant, right? So we are solving some of them, but there are going to be others as well. So now moving further, find the nth term of the sequence. So again the question from the paper of February, March 24 from the variant 2-2. So we can see this thing that it is multiplied with 3, right? Multiplied with 3, again multiplied with 3, right? So clearly if I talk about, this is a geometric progression or an exponential sequence where if I talk about the common ratio, that is 3. So in order to get the nth term, it is going to be u1 r raised to the power n minus 1. So if I talk about the first term is 1, where r, the common ratio is 3 raised to the power n minus 1. So that means if I talk about the nth term of the sequence, so nth term of the sequence is going to 3 raised to the power n minus 1. Clear? Yes? Moving to the next question here, which is from the paper of February, March 24 from the variant 1-2. The question here says, these are the first 5 terms of a different sequence, 2, 9, 16, 23, 30. Find the nth term. So for finding the nth term, we need to understand the relation between the consecutive terms. So here if I talk about, this is plus 7, again this is a plus 7, again this is a plus 7, again this is a plus 7 sequence, correct? So the nth term would be equal to u1 plus n minus 1 multiplied with d. So first term is 2 plus n minus 1 multiplied with the common difference, which is 7. So it is going to be 2 plus 7n minus 7. So if I talk about the answer, the nth term is going to be 7n minus 5. Is that clear? Yes? Now moving to the next question here, which is again a question from the paper of October-November 23 from the variant 4-1. So here the table shows the first 4 terms of the sequences A, B and C. Complete the table for the 3 sequences. So here if I talk about for the first sequence, for the A sequence, if we'll just observe, we can see this thing that there is a plus 4 happening. Can we observe? So in order to get the 5th term, we will be having plus 4, which is going to be 9, right? So for getting the nth term of the sequence, right, for the sequence A, if I talk about, so in that case, it is going to, the first term is minus 7 plus n minus 1 multiplied with the common difference, that is 4. So this is going to be minus 4 plus 4n minus 4, right? So this is going to be 4n minus 11. That is the nth term of the sequence. So we'll just fill this box with 4n minus 11. Clear? Now moving to the next sequence, if we'll just observe, I'll just write this particular sequence here. I'm just writing the B sequence. So it says 7, 13, 23, 37, right? So this is going to, if I talk about the common difference here, so that is going to be equal to 13 minus 7 is 6, right? Here if I talk about it is 10. Here if I talk about it is coming out to be 14. So here it is 4. Then again it is a 4, right? So what we can observe here is that it is a quadratic sequence, correct? So clearly if I talk about, what we are going to do is, it is going, the general formula, if we talk about, it is going to be of the sequence an square plus bn plus c, as we have learned. So that is going to be, we know this thing that 2a would be equal to 4. So that means a would be equal to 2 is what we are going to get here, right? Further, if I talk about the second one here, so here 3a plus b would be equal to, the 3a plus b would be equal to 6, right? So that means we are going to get b is equal to 0. And also we know this thing that a plus b plus c would be equal to 7. So that is going to be 2 plus 0 plus c is equal to 7. So we are getting c is equal to 5. So clearly if I talk about the sequence that we can observe here is that the general formula goes as 2n square plus 5, correct? So in order to get the value here, so we can just check it, maybe 1 for x is, for n is equal to 4. For n is equal to 4, it is going to be 16 multiplied with 2, which is 32, plus 5, that is 37. So that means we are getting the right form here. So if we need to put n is equal to 5 in this, n is equal to 5 is, n square is 25, multiplied with 2 is 50, 50 plus 5 is 55. So that is what we are going to get as the answer here, correct? Now moving to the next term here, to the C sequence, what we can observe in the C sequence, the numerator goes as 2, 3, 4, 5. So clearly the next numerator is going to be nothing but 6 here, right? While if I talk about the denominator, it goes as 3 cube, then 3 raised to the power 4, then 3 raised to the power 5, then 3 raised to the power 6, 3 raised to the power 5, 3 raised to the power 6, then we'll have is 3 raised to the power 7. So let's just calculate what it is going to be. So we are getting it as 2187. Correct? So later on, if I talk about the nth term here, so that is going to be nothing but n plus 1, right? And here if I talk about, it is going to be 3 raised to the power n plus 2. That is what we are going to get as the nth term for this particular sequence. Understood? Now moving to the next question, which is again a question from the paper of October-November 23 from the variant 4.1. Let's read and understand what the question was all about. In a sequence, the sum of the first 49 terms is 7644 and the sum of the first 50 terms is 7955. Find the 50th term of the sequence. So in order to get the 50th term, right, it is nothing but the sum of the 50 terms minus the sum of the 49 terms, right? So this is going to be 7975 minus 7644. That is what we are getting here. So if I talk about that, what is going to be a 50th term here? So that is going to be 331. Okay? Yeah. Clear? Now, moving to the next question, which is again a question from the paper of October-November 23 from the variant 3.3. So, these are the first 4 diagrams in a sequence. The diagrams are made using dots and lines. Just in case you need this solution to this entire papers as well, you will be finding it in the other videos of mine. Okay. So, talking about the question here, the diagrams are made using dots and lines. So, we are being provided with the certain diagrams. We need to complete the table. So, here, the number of small squares are when n is equal to 1, in the diagram 1 it is 2, in the second one it is 4, in the third one it is 6, in the fourth one it is going to be equal to 8, right? So I'll just fill this particular blank with number 8. Now if we talk about the number of dots in that, so it goes as 6, 9, 12, and further if I talk about what we will be observing here is the number of dots when n is equal to 4 here, so that is going to be 15. Yes, so we'll just fill this box with the number 15. correct? So number of lines, if I talk about, is 7, 12, 17, 4. So what we can observe that the number of lines are increasing by 5, correct? So again it is going to be increased by 5 and it will be 22 now. Is that clear? Now moving to the next B part of the question, that says complete. So we have completed this particular part. So talking about the B statement, it says a diagram in this sequence cannot have 51 small squares. Why the diagram cannot have 51 small squares? Because the number of squares here are even. Okay. So if we need to write the reason here, it is nothing but number of squares are even and 51 is an odd number. Clear? Now, moving to the next sub part of the question, which says an expression for the number of dots in diagram n is equal to 3n plus 3, which diagram will have 249 dots. So that means we are going to equate 249 with 3n plus 3, right? So clearly we will be getting 246 is equal to 3n. So we will be getting n is equal to 246 over 3, which is going to be nothing but 82. So the 82th diagram will be having 249 dots. Is that clear? Now, moving to the next question, which is a question from the paper of October-November 23 from the variant 2-2. The question here says, we need to find the nth term of this sequence. So, firstly, let's just understand what the sequence is all about. This sequence is a -3 sequence, correct? That is what we are doing here. So, in order to get the nth term here, so that is going to be the first term, which is 11 plus n minus 1 multiplied with the common difference, which is -3 here. So, un will be equal to 3. 11 plus, sorry, there's going to be a minus now, minus 3n plus 3. So, we will be getting the nth term of this as nothing but 14 minus 3n. Clear? Moving to the next pattern that we can observe here is, so it is the common ratio here that we can observe is 5, correct? So, clearly if I need to get the nth term here, that is going to be the first term multiplied with the common ratio raised to the power n minus 1, correct? So, that is going to be nothing but 5 raised to the power n minus 1 is the nth term of this particular sequence. Clear? Moving to the next question now. These are the first 4 terms in a sequence, right? We need to find the next term and explain how you worked out your answer. So, again it is a previous year question from the paper of October-November 23 from the variant 1-2. So, as we need to get the next term, what we can observe that it says a pattern of +7, correct? So, clearly in order to get the next term, we'll do 18 plus 7 and we'll get the next term as 18 plus 7, which is equal to 25, correct? So, now how we worked out our answer? So, it is an arithmetic sequence with common difference of 7. Clear? So, this is how we have worked out our answer. Moving to the next question, which is again a previous year question from the paper of May-June 23 from the variant 2-3. These are the first 4 terms of a sequence. The nth term of the sequence is 1 over 4n cube plus an square plus bn. Calculate the value of a and b here. Right? So, firstly, we are being provided with that what is the formula for finding the nth term of the sequence. So, what we will do firstly, let's just put n is equal to 1. In that case, what will happen? That 1 over 4 n cube plus a multiplied with n square plus bn, right? What it is? Yeah, b multiplied with 1 will be equal to 2.75, correct? So, this is going to be nothing but 1 over 4 plus a plus b is equal to, so further can we write just this 2.75 as nothing but 11 over 4? Yes. So, clearly if I talk about the value of a plus b that we are getting here is nothing but 10 over 4, which is going to be 5 over 2. That is the value of a plus b that we are getting. So, clearly if we need to get the value of 2 unknowns, we need 2 equations, right? So, let's just make the second equation now. So, in order to make the second equation, let's just put n is equal to 2 now. Right, so when we'll put n is equal to 2, it is going to be 1 over 4, 2 cube plus a 2 square plus b multiplied with 2 is equal to 6 is what we are getting here, right? So it is going to be 8 over 4 is nothing but 2 plus 4a plus 2b is equal to 6. So we are getting here as 4a plus 2b is equal to 4. So later on we can just divide this entire equation by 2 and get 2a plus b is equal to 2. That is what we are getting here, right? So let's just substitute the values now. Yes, so from here what we can do is we can get the value of a is equal to nothing but 5 over 2 minus b. So I'm just going to substitute the value here. So this is going to be 2 multiplied with what we are having here as the value of a is 5 over 2 minus b, right? 5 over 2 minus b plus b is equal to 2, right? So this is going to be 5 minus 2b plus b is minus b is equal to 2, right? So here if we'll be solving it, we are getting this as 5 minus b is equal to 2 is what we are getting here. Let me just check once. So we are getting the value of b is equal to nothing but 3, right? Later on, if we talk about finding the value of a is nothing but equal to 5 over 2 minus b, right? So that is going to be 5 over 2 minus 3. So what we are getting here is a is equal to minus 1 over 2. So just writing both the answers here. I'm just writing it at one place that a is equal to, we are getting it as minus 1 over 2 while we are getting the value of b is equal to 3 here. Is that clear? Now, moving to the next question, which is a question from the paper of May June 23 from the variant 1-1. The nth term of the sequence is 10 minus n square. Write down the first 3 terms of the sequence. So in order to write the first 3 terms, we will be taking n is equal to 1. In that case, the first term would be equal to 10 minus 1 square, which is equal to 9. If I take n is equal to 2, in that case, the next term is going to be 10 minus 2 square, which is going to be equal to 10 minus 4, that is nothing but 6. And when n is equal to 3, the third term is going to be 10 minus 3 square, which is going to be 10 minus 9, that is nothing but 1. So these are going to be the first 3 terms of the given sequence. Moving to the B sub part of the question, which says these are the first 4 terms of another sequence. Find an expression for the nth term. So let's just find out that what is happening in this particular pattern. So in this particular pattern, we have a plus 3, right? So clearly, if I talk about the common difference that we have got here is a 3, right? And so that means that it is an arithmetic sequence. So in order to get the general term here, right, this is going to be un would be equal to u plus n minus 1 multiplied with d. So that is going to be the first term is 7 plus n minus 1 multiplied with the common difference that is 3. So this is going to be 7 plus 3n minus 3. So talking about the final answer, we are getting the nth term here as nothing but 3n plus 4. I hope that we have understood this particular question. Okay, so this is all that we need to do for the topic of sequence, right? I'll be meeting you in the next session where we will be discussing one more topic from the chapter Algebra and Graphs. So that's all that we had to do for today for this session. Till then, stay connected.